Okay, Math 8 students, Module 8 review is here. We're going to try and get through this quickly and concisely to cover everything that we have done in Module 3, Lesson 3.1, Lesson 3.2, Lesson 3.3. So, overarching idea here is that we are talking about proportional relationships. And a relationship between two quantities in which the ratio, I've got color, but your guys' notes will be black and white, the ratio of one quantity to the other is constant, meaning it does not change. The ratio does not change. Oops, ratio. If it changes, we call it variable. It has a variable rate of change if it is not constant. The equation of a proportional relationship is y equals k times x, where k is the constant of proportionality, and we can write that as y equals k times x, or k equals y over x. You can find the constant of proportionality, k, by using tables, graphs, and equations. In proportional relationships, where the ratio of two variables is constant, the constant of proportionality is equal to the slope is equal to the rate of change. So this is kind of what we connected in all of our notes and all of our practice this week, is that the constant of proportionality, k, is equal to slope, m, is equal to rate of change. Right? So, constant of proportionality is equal to slope is equal to rate of change. So what we're going to do here is we're going to go ahead and give a couple examples of how to find those things. Actually, I'm going to give you the equations and relationships first. So the constant of proportionality which is the equation where y equals k times x, and you can find k by putting y over x. So those are two ways to write that. And that is equal to the slope, right? And remember, this is in proportional relationships. That's the key thing here. In proportional relationships. So slope is, we use m, and as a change in y over change in x, or we write that as y equals m times x. So m and k are in the same spot here. It's our y over x to find k, and our change in y over our change in x to find m. So essentially, these are the same thing. Remember this little triangle here that indicates change. And these two are equal to rate of change. Which we have as the change in y values, or we call this what? The dependent variable, over the change in x values, which is our independent variable. Remember, this is also, so these are three ways to essentially find the same thing. Why we have three different applications for them depends on our situation. So this is all for proportional relationships. Constant of proportionality k, slope m, and rate of change. Remember that our little tangent here, a unit rate, is when it's the second quantity, or x, equals 1, right? If it's y over x, it's when x equals 1. So let's go ahead and do a couple examples of these. And we can find unit rate with tables, unit rate, constant of proportionality, and slope, all of these with tables. So if we are going to have a table here, I'm going to draw a table here real quick for you guys. And let's just go ahead and give it 1, 2, 3, 4. The number of cells that it has is not entirely important, but so this would be our x, and this is our y in our table. If we have a
meeting happening in the conference room with the new feng shui sideways table. We're all going to stand on our heads doing headstands in here to see this thing a little bit better. Foundations meeting, conference room.
Alright, sorry about that. Just had a little announcement over the intercom. So we have tables here horizontally where x value will be on top and y value will be on bottom, or your independent variable on top and your dependent variable on bottom. If we have a horizontal table, you're going to have your x value on the left and your y value on the right. X and y, we can also think of that as input and output, but we'll get to that a little bit later when we talk about functions down the road. So we can think about this here as we've got this is our first x value, our second x value, our third x value, and our fourth x value. Same thing here, x1, x2, x3, x4. And then for our y values, we would have y1, y2, y3, and these are little subscripts, y4, y1, y2, y3, y4. And so what we're doing when we have tables is we're finding that change between our x values and our y values. And then we're creating a ratio of the two. So if we're finding slope, that's going to be our m equals our change in y values, right? And that would be y2 minus y1 over our change in x values, which is x2 minus x1. So all that's saying is that you would subtract these values here. So you would subtract x2 minus x1, y2 minus y1 to find your slope. So we're going to do an example here real quick. I'm drawing another little table. X values on top, y values on bottom, independent variable on top, dependent variable on bottom. We're just going to say 4, 8, 12, 16, 2, 4, 6, 8. Okay, so I have a table and it represents something, some relationship of two variables. And so what I'm going to do to find slope, or constant of proportionality, or unit rate, because they are all the same thing in proportional relationships, is I'm going to find my change in y over my change in x. So I'm going to look at these first two values here, and I've got, for x, I've got 8 minus 4, which is my change in x values. And then I'm going to look at the corresponding y values. So 8's corresponding y value is 4 here. 4 minus the corresponding y value here, which is 2. So my change in y I'm looking at here is 4 minus 2. And my change in x that I'm looking at here is 8 minus 4. I'm trying to find the difference. I'm trying to find the change in the values. So 4 minus 2 is 2. 8 minus 4 is 4. So my slope, my rate of change, my constant of proportionality is 2 over 4. And that simplifies to 1 over 2. So my slope would be 1/2. I'm not sure why I've got this written here, reviewing class. And I would write that in an equation as y equals 1/2 x. And that could be for y equals k times x, or y equals m times x, or y equals unit rate times x. Okay, so that's tables. I'm just going to separate these here. Now let's look at how we can do equations. So if I've got 3 equations here, I'm just going to give you 3 examples. Remember that I've got my equation is y equals k times x, or y equals m times x. This is the constant of proportionality. This is the slope. In proportional relationships, they are the same thing. I'm saying that a lot because it's important. So if we have an equation like this, y equals 2.75x, what is our slope or rate of change? Well, since it's in this format that we're familiar with, this is our slope, this is our rate of change. So m or k, depending on what they're asking for, would be 2.75. That's pretty straightforward, huh? What if you have this equation here, y equals 3/8 x? Well, one more time, since this is in the format we are familiar with, where it's either k or m, depending on what they're asking for, that is slope, or constant of proportionality, is equal to 3/8. So we're just pulling that number there out of that format. And if I'm just going to do one more example here. If I've got the equation y equals 15x, and there may or may not be parentheses. This example here does not have parentheses. This example does. This example does not. It does not matter. That number in the middle will be your constant of proportionality, or your slope, or your unit rate, depending on what it's asking for. And so 15 right here is my constant of proportionality, or my slope. It's slope. Here I'm using the m, but I could have wrote k equals 15. I could have wrote unit rate equals 15. Unit rate I would have probably wrote 15/1. Right? And even for slope too, because this means I'm going up 15 and over 1. Up 3 and over 8. Okay, so that's equations. Equations are probably the most straightforward of them. I'm going to go ahead and draw just another line here to separate these. And then graphs. We're going to look at graphs. So let's go ahead, and I'm going to draw just an example graph here real quick. I know I'm having you guys draw a lot this time. A lot of extra writing. And this is my y-axis always, and this is my x-axis always. And let's say I've got this line running through, and it's a proportional relationship because it is a straight line through the origin. That origin, remember, represents 0, 0. So what I'm going to do to find slope with a graph is I'm going to pick 2 points on my graph. And when you're picking these points, you do want to make sure that they're intersecting at x and y values, right? So that they're hitting points on the graph that are actual corners of those x and y, so you can get a clear value for each of those. You can get a clear point for each of those. And what I'm going to do on a graph to find slope is I'm going to count my rise, which is my change in y values. And I'm going to count my run, which is my change in x values. And that's my slope. Graphs are nice and easy. They're pretty straightforward. So if I was going to write that down, slope or constant of proportionality, if they gave you a graph and they wanted you to find the constant of proportionality, they might ask you to make a table and then find the constant of proportionality. But you can find them the same way. So I found my rise and my run. This is a positive slope. And so that's my change in y, which is my rise. I'm going to go ahead and put that in red because that's the color we used, which is my horizontal change. Remember, it can be positive or negative over my change in x, which is my run, which is our horizontal change. And then you'll write that in the form y equals m times x. Graphs are nice. Very visual. If you're a visual person like me, graphs are going to be one of the easiest ways to go with this. And, you know, I'm actually going to do one more here, and that would be ordered pairs. Because they did have a couple examples where they gave you some ordered pairs, and they said find the constant of proportionality, or find the rate of change, or find the slope. So we're just going to take a little side trip here and talk about ordered pairs for a second. And so ordered pairs you can pull from a table, right? This would be an ordered pair. You can pull from a graph. These would be your ordered pairs, right? x1, y1, x... Give myself a little more space here. x2, y2. So these are ordered pairs also, right? Or they might just say, give you a pair of numbers and tell you to find the constant of proportionality or the slope. So let's say we have the ordered pair 3, 7, x is 3, y is 7, and the second pair is x is 4, y is 9. Okay, so remember that what we're looking at here is x1, y1, and x2, y2. Why am I telling you this? Because it applies down the line and we want to make sure that we can connect our concepts. So we're going to find our change in y values here. So we're going to do m equals change in y over change in x. And so our change in y values here are going to be 9 minus 7. 9 minus 7 is what? 9 minus 7 is 2. And then we're going to look at our change in x values here. So that's going to be our corresponding values, right? Which is 4 minus 3. And 4 minus 3 is 1. So this is telling us that our slope is 2 over 1, or 2. Now what this means, just going to do a little more space here, is that if I was going to graph this, a slope of 2, or 2 over 1, because anytime you have a whole number, you need to put it over 1 for slope. A slope of 2 over 1 says that I'm going up 2 and over 1. This is a positive slope. If this was a negative slope, I'm just going to give you another example here of a negative slope. Let's say slope is negative 3 over 2. And in this case, you would be going down 3 and over 2. You're always going to be traveling to the right because that's how we read our graphs, is from left to right. So this is a positive slope, this is a negative slope. This is just another example. This has nothing to do with those order pairs. Okay, so that is the quick, hopefully quick, and comprehensive version of what we have done this last module. So remember, here's the big thing, is that constant of proportionality is equal to slope is equal to rate of change. So no matter what they're asking for, if it wants you to find the constant of proportionality, if it wants you to find the slope, if it wants you to find the rate of change, you can use the same method for solving. And that would be, depending on what you've been given, if you've been given tables, you got this method here. If you've been given equations, you've got this right here. Graphs may not always be in this quadrant, but we find slope the same way. And if you've got ordered pairs. Okay, so you've got a review assignment on page 89, and it's 6 questions. I'd like you to go ahead and try and do that assignment. I am going to post a second video that shows the walkthrough of all of those questions, shows how to do all of those questions. So if you need more review after you've done the review assignment, you want to make sure you've done them correctly, then go ahead and watch that video. It'll be the ready to go on walkthrough for Module 3 review. All right, that's it for now.